Alright, I'm going to be going over the review for 4.1 to 4.4, which is our unit circle and trig units. For number 1, this section asks you to draw a picture and find the reference angle, which we call alpha. So for your picture, you're going to have your quadrants, your x and y axis, and you're going to need to figure out where the terminal side of your angle is. Remember, your initial side is the positive x-axis. So if we're going in the negative direction, negative is actually clockwise, and we're counting by pi thirds, and we're going to go 4 pi thirds. So this would be 1/3, 2/3, 3/3, 4/3. Don't forget in your picture to draw your arrow showing what direction you went in and how many times you went around. So we went in the negative direction and stopped when we got there. We didn't do a full circle and then go. So make sure you draw your arrows, especially on your test. I'll take off points if you don't. Okay, and then they ask you for the reference angle. Remember, the reference angle is the distance from the terminal side to the nearest x-axis, which in this case is the negative x-axis. So this right here is your reference angle, and we'll call that alpha. Okay, so if this was all the way to negative 4 pi thirds, the distance from here to here is going to be pi thirds. Because 3/3 is half a circle, pi, and so we went 1/3 farther. It is never negative. Your reference angle is always positive. Same instructions here. Draw the XY axis. Now we're going in the positive direction, so we're going to go counterclockwise, counting by pi 6, that's your 30 degrees. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Draw your arrow. And then your reference angle is to the nearest x-axis. And in this case, alpha is pi 6. We are 1 pi 6 short of 12/6, which would be 2 pi. And remember, a full circle would be 2 pi. Half a circle is pi. Okay, next ones are the same set of instructions. Now this one's given to you in degrees. Negative 60 degrees is going to be in quadrant 4. And you need to show your arrow that you went in the negative direction to get there. In this case, your theta, what they gave you, and your reference angle are actually equal besides the sine. So this is a 60-degree angle. Notice here I'm giving my answer in degrees because my angle was given in degrees. On the last ones I gave my answer in radians because the angle was given in radians. Make sure you match those answers. I will take off points on the test if you don't. Okay, 870 degrees. Okay, we're going in the positive direction, counterclockwise. The easiest way to figure out how many times around this is going to be is to figure out, we know a circle is 360, and so this 870 is going to be at least 2 circles, because 360 and 360 is 720. So past 720 is how much we need to figure we're going to go, which is 150. So this is going to end up in quadrant 2 at 150 degrees, and then draw that very accurately. It's going to be more like here. Okay, and to show you again how I got there, I went 360, 720, and another 150. That got me around to 870 degrees. That's why it's so important for these arrows to show me you went 2 full circles and another 150. So your reference angle, if you're at 150, this is 180, your reference angle is 30 degrees. Okay, next section, you're given a point and asked for the trig functions. Plot your point. 3, 3 is in quadrant 1, so my picture, I just have to have it of quadrant 1. Okay, so 3, 3, that's x and y. So x over 3, y up 3. And then remember, this is my radius, r. I can find r by doing Pythagorean theorem. So I'm going to take 3 squared and 3 squared. When you take the square root to get your radius, remember the radius is always going to be positive. Okay, so we're going to say positive out of these two. But we can also reduce this, and I will, again, another thing I'll take points off on is if you don't reduce your radicals or your fractions. So here, think about 18. 18 has factors of 9 and 2. 2 is prime, it stops. 9 can keep going to 3 and 3. Okay, so when you have a pair, it can come outside, but 2 doesn't have a pair, so he has to stay inside. So 3 square root of 2. And if you're not sure if you're reducing your radicals correctly, you can check it in the calculator, but I think on this part of the test I told you you're not going to have a calculator, so never mind, you won't be able to check that. But if you were doing this on, say, a tax test or an AccuPlacer or SAT, and you had to reduce radicals, you can check it in the calculator by just typing this in and this in and seeing if you get the same decimal. Alright, so r is 3 square root of 2. So I'm going to list my 6 trig functions out here because that's what they're asking for. Alright, now you need to remember that sine is the ratio of y to r, cosine is x to r, and tangent is y to x. So sine, y is 3, r is square root of 3 square root of 2. Do not leave your answers in this form. I will take points off. You need to rationalize this. You do not have to do anything with this 3 in front. Whenever you have a radical that has a constant in front, don't worry about the constant. That doesn't have anything to do with rationalizing. It's the radical that we have to rationalize. In fact, here, this 3 is going to cancel out. So you end up with a 1 here. So in your numerator, it's just square root of 2, and in your denominator, 2. For cosine, you could do this same process, or you could realize this is an isosceles triangle. These are going to be the same. So cosine is also 3 over 3 square root of 2, which will reduce again to square root of 2 over 2. Tangent is y over x. 3 over 3 is just 1. Then you would list your reciprocals. Remember, when you're taking a reciprocal of a term with a radical in it, go back to the original before you rationalized and flip that. Because if I were to flip this one, I end up with a radical in the denominator again, and I have to re-rationalize. So it'll just save you a step to go back to the original and flip it. So if I flip this original, the 3's canceled out, so it was just 1 over square root of 2, so it's just square root of 2 over 1. Which is just square root of 2. Same thing's going to happen here. This is the same number, so the reciprocal will be the same. Reciprocal of 1 is 1. Okay, 6 is going to be the same process. Actually, I don't need to draw that whole thing. We only need the specific quadrant that we're in. 8 -2 is going to be in quadrant 4. So that means we go over 8, down 2, and I need to find my r. So I can do Pythagorean theorem. -2 squared plus 8 squared equals our radius squared. That gives me 4 and 64. I take the square root. I'm finding r, so I'm definitely going to use the positive, but I can factor this. Okay, so 68, it doesn't really matter what you start with. You can keep going. 68 is divisible by 4. It's 4 and 17. And the 17, the only factors are 1 and 17. That's a prime number. But 4, you can go to 2 and 2. So I have this pair that can come out. 17 has to stay under. So it's 2 square root of 17. Now when you go over here to list your trig functions, same ratios as the last problem. Y to r, x to r, and y to x. Alright, so in our triangle, our y value is -2. Our r is 2 square root of 17. This is another one you're going to have to rationalize again. Again, we have our numerator and denominator's constants are the same, so I can cancel them. It's just going to be a -1. But I'm going to multiply by square root of 17. So I have negative square root of 17 over 17. And then for cosine, it won't be the same this time. This isn't isosceles anymore. It'll be 8 over 2 square root of 17. 8 divided by 2 is just 4. And I need to rationalize the square root of 17. So 4 square root of 17 over 17. Tangent y is -2, x is 8. Reduce this, -1/4. And then of course you need to do your reciprocals. Oops. Alright, so cosecant will be the reciprocal of the original. 2's still cancel. So instead of 1 over square root of 17, it's square root of 17 over 1, and it is negative, so the reciprocal is negative. Secant is the reciprocal of cosine. Okay, so that 4 still is the reduced number, so 4 over square root of 17, it's going to end up being square root of 17 over 4. Reciprocal of -1/4 is just -4. Make sure you do your signs correctly. If cosine's negative, or I'm sorry, cosine's positive, secant's positive. Sine's negative, so cosecant's negative. And make sure that that corresponds to your quadrant as well. So in quadrant 4, cosine should be positive, and its reciprocal, the rest are negative.